Hey everyone, and welcome back. Get ready because today we're taking a deep dive into Neuralink, a company that's pushing the boundaries of what's possible.
Yeah, it's pretty mind-blowing stuff. They're working on merging minds and machines, a concept that used to be pure science fiction.
I know, right? It sounds like something out of a movie, but it's actually happening.
And it all started back in 2016 with this ambitious goal to create a seamless interface between the human brain and technology.
Okay, so let's break this down. Neuralink's aim is to build a system that allows our brains to talk directly to computers.
Exactly. Think of it like a universal translator for the brain. Imagine being able to control your devices, access information, maybe even experience totally new sensations, all with just your thoughts.
Whoa, that's a lot to take in. So how are they actually making this happen?
Well, it all begins with understanding the language of the brain. You know those electrical signals that neurons use to communicate? Neuralink developed these incredibly thin, flexible threads. They're thinner than a human hair, and they're packed with these tiny electrodes.
So they implant these threads into the brain.
Yep, and that's where they can detect and record the activity of individual neurons.
So it's basically eavesdropping on the brain's conversations. But how do they even get those threads in there? It sounds pretty delicate.
It is an incredibly precise procedure, and that's where their R1 surgical robot comes in.
A surgical robot.
Yeah.
Okay, things just got real futuristic. So this robot implants the threads, and then what?
Well, it minimizes the risk to the surrounding brain tissue. It's pretty remarkable how Neuralink is pushing the limits in both neuroscience and neurosurgery. The signals from the threads are sent wirelessly to the small implantable device called the N1 link.
Okay, so it's like a little computer sitting just below the skull.
You got it. And that device processes and amplifies those signals and then sends them to an external device, like your phone or computer, running the Neuralink application.
So is the application the thing that decodes all those brain signals and turns them into something a computer can actually understand?
That's exactly it. That's where the real magic happens. The application translates those signals into actions, things like moving a cursor, typing text, even controlling a robotic arm. It's like a bridge between thought and action in a way that we've never seen before.
This is blowing my mind. So they've actually gotten this to work.
Oh, absolutely. You remember Pager, the macaque monkey who became kind of a Neuralink celebrity?
We Pager, what did he do?
He actually learned to play Pong, you know that classic video game, using only his mind. He had the N1 link implanted in his brain.
Seriously, a monkey playing video games with its thoughts. That's just insane. How's that even possible?
Well, Pager had over 2,000 electrodes implanted in his motor cortex. That's the part of the brain that controls movement.
Right.
So as Pager was thinking about moving his hand, the electrodes were picking up on that corresponding brain activity. And the decoder algorithm, which is kind of the brain of the Neuralink application, learned to recognize those patterns and translate them into cursor movements on the screen.
So he was literally controlling the game with his thoughts.
Yep. They even unplugged his joystick to prove he wasn't using it. He was playing Pong just with his mind.
That is wild. It's like something out of a sci-fi movie, but it's really happening.
And it was a pivotal moment for Neuralink. It showed that their technology could turn thoughts into action, like in real time. And even more importantly, it really paved the way for them to start human trials.
Which brings us to the PRIME study.
Right.
Neuralink's groundbreaking first-in-human clinical trial.
It started this year in 2024.
That's where things get really interesting, wouldn't you say?
Oh, yeah, for sure. You remember Nolan, the first person to receive the N1 link implant?
Yeah, Nolan's case was incredible.
He's paralyzed from the shoulders down, but with the link, he can control a computer cursor, just like Pager was doing with the video game.
So he's playing chess online, browsing the web, all with just his thoughts.
Exactly. It's pretty remarkable. He's even learning new languages with the link. He actually stayed up until 6 a.m. playing Civilization VI. Imagine what this means for people with limited mobility. The sense of agency and control it can give them back. It's opening up a whole new world.
Wow, that is truly powerful. I also heard they've implanted the N1 link in a second participant.
They have. His name's Alex, and he's the second participant in the PRIME study. He's always been passionate about building and designing things, and now with the link, he can take that passion to a whole new level.
That's amazing. Is he like controlling CAD software or something?
Exactly. Within 5 minutes of connecting to a computer, he was controlling a cursor with his mind, and he quickly surpassed the maximum speed and accuracy he had ever achieved before. He even used CAD software to design this custom mount for his Neuralink charger, and then he had it 3D printed.
Wow, he's really taking control.
He is. He's even figured out how to combine the link with his quad stick, which he uses to control his wheelchair so he can play first-person shooter games. He can move and aim at the same time, which makes for a much more intuitive and immersive gaming experience.
That's amazing. I'm starting to see why everyone's so excited about Neuralink. It's not just about the tech itself, but it's about the potential it unlocks for human ingenuity, for empowerment.
It really is. And this is just the beginning. Neuralink is constantly refining its technology. They're exploring new applications and pushing the boundaries of what we thought was even possible.
This is all incredibly fascinating, but I have to admit, I'm still a little fuzzy on how all the pieces of this system work together. Can we maybe dig a little deeper into the technical stuff, the nuts and bolts of how it all works?
Of course. Let's take a closer look.
Perfect. Time to get my geek on. Okay, so we've seen what Neuralink's tech can do, but I'm ready to go a bit deeper. How does this mind-machine connection actually work?
It's a really intricate interplay of three main components. Those superfine threads we talked about, the N1 Link implant, and the Neuralink application.
Right, the threads are like the sensors, picking up the brain's electrical signals.
Exactly. And remember, each thread has over 1,000 electrodes, making it super sensitive to the activity of those individual neurons.
So they're gathering a huge amount of data from the brain. What happens to all that information?
That's where the N1 Link comes in. It's this tiny marvel. It houses the electronics that process and transmit all the neural data wirelessly.
Like a tiny, super powerful computer tucked under the skull.
Precisely. The link acts as a bridge between the brain and the outside world, taking signals from the threads and sending them over to the Neuralink application.
So the application is like the command center, figuring out what those brain signals actually mean.
You got it. The application is where the real decoding magic happens. It uses really complex algorithms to interpret those neural patterns and turn them into actions or commands that a computer can understand.
So it's like learning the language of the brain and then teaching it to the computer.
And that's a great way to put it. And the applications for this are vast. Right now, Neuralink is focused on helping people with paralysis regain control over digital devices. But in the future, who knows what's possible?
It's mind-blowing to think about the potential, like controlling our surroundings with our thoughts, communicating without speaking, even boosting our cognitive abilities.
The possibilities are truly exciting. But it's important to remember Neuralink is still a young company, and this technology is in its early stages.
Right. There are still challenges and questions to be answered. Speaking of questions, I'm curious about the implantation. How do they get those delicate threads into the brain without causing damage?
That's where the R1 surgical robot comes in. It's designed to perform the implantation with incredible precision and minimal invasion.
So it's not just the technology itself, it's also the cutting-edge surgical techniques that make this possible.
Exactly. Neuralink's pushing boundaries on multiple fronts, combining neuroscience, engineering, and surgery to bring this revolutionary technology to life.
It's a remarkable feat of innovation. I'm so eager to see how it evolves and what impact it will have on all our lives in the years to come. Well, we've explored Neuralink's origins, dug into the tech, and even seen its potential in action. Now, wondering, what's next? What does the future hold for this company and its incredible innovations?
It's a great question. It's tough to predict the future, but if we look at what Neuralink's done so far, they seem to be aiming for a future where brain-computer interfaces are as common as, say, smartphones.
Wow, that's ambitious. So are you saying we could see a time when people get Neuralink implants not just for medical reasons, but just for everyday life?
It's definitely a possibility. Think about controlling your house, your car, even your social media, all just with your thoughts. It sounds like something straight out of a movie, but Neuralink is really working towards making that happen.
It's incredible. But wouldn't that bring a whole bunch of ethical questions too? I mean, privacy concerns, potential for misuse, even the idea that technology could influence our thoughts.
You're right. Like any groundbreaking tech, there are potential risks and ethical considerations. That's why open discussions and smart regulations are super important as this technology keeps developing.
Absolutely. We need to think about these concerns now before it becomes so widespread that it's hard to control.
Exactly. We need to shape the future we want to create with this technology, make sure it's used ethically, for good.
And what about accessibility? Will Neuralink be available to everyone? Or will it be something only a select few can access?
That's a crucial question. Neuralink has said they're committed to making their technology available to as many people as possible, but it's complicated. You've got costs, infrastructure, ethical factors. It all plays a role.
Well, I hope they can make good on their promise. It would be a shame if such a game-changing technology ended up creating even bigger divides.
I agree. We should aim for a future where Neuralink empowers everyone, no matter their background.
It's been a truly mind-blowing journey into the world of Neuralink. Thanks for guiding us through it.
My pleasure. And to our listeners, stay curious, keep exploring, and be part of the conversation about the future of this amazing technology.
Great advice. Thanks for joining us on the deep dive. And until next time, keep those minds engaged.